right, we're gonna take our breadboard. Now we've got power to it. We've got our little logic probe circuit connected to it. What I'm gonna do now is I'm gonna install an AND gate. And so in class or wherever you've read about how an AND gate works, basically an AND gate is something that if you put two ones in for the inputs, A and B, then you're gonna get an output of 1. If either one of the inputs are a 0, your output's going to be a 0. Unfortunately for us, the logic functions kind of describe what it does. So if A and B are 1, then Y is a 1. Otherwise, Y is a 0. So that's the function. So we're going to try it out and see if it works. Now here is the AND chip. If you haven't already, you need to download the data sheet for this AND chip. It's the part number's on your lab kit. This one, it's written on the top, but you're not going to be able to read it because it's just not going to focus in on it, and plus it's kind of dim. It is made by TI, Texas Instruments. It's the SN74HC08N. So I just read that right off the top. Okay, now one thing to notice about this is that you'll see that there's a little half moon cut out on one end of it. That's important. That tells you which end pin 1 is on. And if I look, this is also detailed on the data sheet. So it'll show you which pin number is which. But starting up here at the top, on that side with the half moon, this would be the top left, that's pin 1. And then you keep counting all the way down the side to pin 7. You go around the other end, pin 8, all the way back up to 14. Now this kind of package is called a DIP package, and not all chips come in DIP packages. Definitely, this isn't even the most popular package, but it's really good if you're learning, and it's really good to put into this breadboard, so that's why we have it. But all DIP packages count the same. You might have a 28-pin DIP package, in which case you're going to have 1 through 14 on one side, wrap around to 15, back up to 28, right? So half the pins are on one side, the other half on the other side. That's how they always count. Now, it turns out that this chip is made exactly to fit on either side of that trench. And that's not an accident. That's a standard, right? That's good. It's 300 mils, it's a 0.3 inches apart, and so it fits exactly on the other side. Or it would, except that the pins are bent out a little bit and they don't fit exactly in the holes. Now, there's a good reason for that, and that's because when people use these in a factory, in automated assembly machines, the machine stuffs it into the hole, and the fact that the pins are bent out a little bit gives it a little spring tension, and the thing doesn't fall back out of the board again. Well, that's nice, but it doesn't work for us. So what we're going to have to do is we're going to have to take this, and we're going to have to bend these pins in ever so slightly to get it to fit in our board right. So all I'm going to do, and I'm going to have to move the camera to do this, I'm just going to put this on the table, and then when I can let go of the camera here, and I'll have to do this off camera, but I'm going to bend this. Actually, I can do it like this. I'm going to bend it with all those pins against the table ever so slightly so that all 7 of those pins bend in a little bit. Now, how much do they need to bend? So that the part fits in the board right. What if you bend them too much? Screwed up, you're going to have to get another part. But don't worry about it. It's all right. What if you don't bend them enough? Well, then you got to bend them a little more again. So just get the feel of it. If you run your chip, go get another one. They're like a quarter. It's going to be okay, all right? So if you find yourself getting stressed out about this stuff, calm down. It's all right. You're going to do fine. All right, so here's this chip. I'm going to put it in the board. Doesn't fit. I've been doing this for 20 years. I still didn't bend it far enough. All right, I bent it a little bit more. Okay, here we go. Taking the chip. See, now when you push that in, you're gonna feel like a satisfying little pop. Yeah, you couldn't really hear it, but there's this nice little snap. And look, the part is down right on the board, okay? Right on it. There's no space in between. What you don't want to do is kind of like halfway plug it in, and then the board, it's not really connected in there. You want to make sure it's really connected in. Okay, so now I got that connected. Now, the beauty of these holes is I can now wire to this just by connecting wires into the holes that are next to the chips. So the first thing I need to do is provide power to these chips, to this chip that I just installed. If you look at the data sheet, there's going to be 2 pins on there that we use to provide power to it. One of them is called VCC. We hook that to 5 volts. VCC is a cryptic name. It makes a lot of sense once you learn how the chip is made on the inside. Right now, it doesn't make any sense, and it doesn't matter. VCC is where power goes, okay? So that's going to be pin 14. Now let's count this off. You see on the top here, that's going to be 1 through 7, 8 through 14. So 14 is going to be this row right here. I'm going to plug this wire in and then show it to you again. There you go. See? So I took a wire and I plugged it into red, and then I plugged it into the same row that pin 14 was on. There you are. Now it turns out that if you put the half moons on the left, I've flipped the board over, by the way, if you weren't paying attention. If you put the half moon on the left, where the writing will be right side up, and then your power line will always be on the upper right for all the chips that we use in the lab. It's not true of every chip in the world. It's true of all the chips that we use. Okay, then if you look on pin 7, that's labeled GND. Sometimes, I think for years it's called GND. That's ground. So we want to hook that to 0 volts. So I'm going to take another wire, and I'm going to connect it to ground. I think I'm going to. The wire's not fitting in so great. I'm using a wire that's a little bit too short. Now we're going to go with it. Okay, let me turn the board to where the moon's on the left again. There you go. So now, I plugged it into the wrong hole. See, I got it into the blue, but this isn't on pin 7 of the chip. See, it goes 1, 2, 3, 4, 5, 6, 7. I plugged it into the hole that's next to it. This is a big problem. It's not connected. This is going to happen to you over and over and over. So you just got to double check things. And later I'll show you some good troubleshooting techniques to find it. But for right now, I can tell it's in the wrong hole. So I just move it. This time being a little more careful. By the way, if your strategy on making good circuits is to never make mistakes, you're going to have a problem, because people always make mistakes. The trick is finding them and fixing them quickly. Look, there it is. It's fixed now. So 1 through 7, and if you look on the data sheet, you'll see 7 is ground, and then you'll see 14 is power. And I've got both of those connected up. And see, I've got my power lines getting in the way. Get out of here. Get over to the side where you're supposed to be. All right, there it is. So now the power is connected up to those two. And you'll notice I use these nice little short wires, right? Again, with the theme of trying to keep the power wiring out of the way so that we can focus on the signal wiring. Okay, what I'm going to do now is I'm going to take a couple of wires and I'm going to connect them to the A and B inputs on that logic gate, and I'm going to test it out. So, let's see. I have a yellow wire and a red wire. Okay. Now if you look again on the data sheet, you'll see that pin 1 is A of the first gate. And I've plugged a wire into pin 1. And so I can plug this wire into either the blue line or the red line. If I plug it into the blue line, it's going to be a 0. If I plug it into the red line, it's going to be a 1. I'm going to start off by plugging it into the blue line. So what I've done there is by plugging that wire into the blue line, I've made A on that first logic gate, that first AND gate in the package, I've made A equals 0. Now I'm going to do the same thing for B. This one's connected to pin 2. I made them different colors so we can tell them a different here. So pin 2 is B, pin 1 is A, and you see I had them both set to 0. Okay. Now I'm going to see what the output is. I'm looking over my power supply to make sure I got it on. I do. So right now, already, the part has calculated what the output Y is. I've made A 0, I've made B 0, that means the output should be 0. And there is a 0, I hope, if the part's working right, there is a 0 sitting on pin 3 right now. How am I going to tell it's a 0? Remember our logic probe from before? I'm going to plug it into pin 3. That's the output of that logic gate. And look, the light's off. That means that the output is a 0. That's what it's supposed to be. Now I'm going to test the other combinations. What if I make A 0 and B 1? Okay. See, what I've done is I've taken B and I've moved it to the red line. A is 0, the red line. B is 1. Oh, I used the red wire. I should have said A is 0 because the red wire is plugged into 0, and B is 1 because the yellow wire is plugged into the red line as 1. Still, it's off, but that's what it's supposed to do because 1 and 0 is 0. Let's try the other combination. Now I'm putting A is equal to 1 and B is equal to 0. Still, it's off because 1 and 0 is 0. So now let's try the one we've been waiting for, which is both A and B are both 1. I know, it's exciting, right? Here we go. Ta-da! Logic works. So now we have A is 1 and B is 1 and the output's 1. So I know that that first gate, that first package, and again, if you're like, how does he know what pins to connect to? You got to download the data sheet, right? You got to have the data sheet with you. In fact, if you watch this video and you didn't have the data sheet, you should go print the data sheet and then come back and watch the video again. But when you're looking at the data sheet, you're going to see what pins connect to what. And you'll see I use pins 1, 2, and 3, and those are connected to that first AND gate in this package. This package has 4 AND gates in it. There's another package with A and B at 4 and 5, and the output Y at 6. And then there's another one that's on the other side of the chip, and another one that's on the other side of the chip, and you'll see it on the data sheet. And to make sure this part really works, we're going to test all 4 of those. Now, in some ways, this is not a particularly useful exercise because we just took it out of the parts bin. We know it's good, but later there's going to be parts and you're going to have to use them for a while, and sometimes your parts are going to go out and they're not going to work like you expect them to. So you're going to need to be able to test them to make sure that they're working properly. And this business of it gives us a good chance to wire up some chips, wire up the power, and then test out logic values using our logic probe. If you didn't get the right values, here's a couple things you can do. You can check to make sure you really do have 5 volts on one of the inputs. So I can connect that logic probe to my input B, and I can see that that's set to 1. You might say, of course it's set to 1. You wired it to 1. I know, but things go wrong, right? Sometimes you don't have the power wiring connected together over here. Sometimes the power supply is off. There's lots of things that can go wrong. So if nothing's making sense, then start checking the things that you think are true, and pretty soon you're going to run across something that you thought was true that turns out not to be true. And that's where your problem is. So that'll help you find it and fix it. All right, so in the lab exercise, I think it asks you to test all 4 of these out and then to do the same thing on an OR gate. I'm not going to do that in this video because it's really just more of the same. But the reason that that stuff's in there is because I want you to get comfortable with wiring, comfortable with changing values from 1s to 0s, and comfortable with just putting chips in and out of the board. It's just the more you do it, the better you get. All right.